So let's carry on with our discussion of VLAN trunking. Now you'll recall we talked about two different trunking protocols, ISL and 802.1q. Let's take a couple of minutes and talk about the differences between these two protocols. First, we'll talk about ISL trunking. ISL stands for Inter-Switch Link. It is a Cisco proprietary protocol. I love the word Cisco proprietary, or proprietary protocol for that matter. It supports pretty much every feature that the 802.1q trunking protocol supports. However, ISL trunking is the old method of trunking. Most modern switch iOS versions don't even support ISL as a valid trunking protocol. In fact, out of the 4 or 5 switches I have in my lab here, I think I only have one that even supports ISL trunking. And that switch is so old that it's practically useless. So how does ISL trunking work at the packet layer? ISL trunking takes a normal Ethernet frame that you see up here in the top part of this graphic, and it slaps an ISL encapsulation around it. So you have the original Ethernet frame that you see here is now right here in this part of the new ISL frame. It has a new ISL header that contains the VLAN and the BPDU, and you don't have to know what all these fields are because, again, it's old and you're probably never going to see it in production. It also has a specialized frame checksum at the end of the ISL frame. So essentially what happens is when a switch sees a frame that goes across an ISL link, it takes the frame, encapsulates it in the ISL protocol. It doesn't change any of the information in the actual frame, the source address, the destination address, the checksum, so on and so forth. It just takes all of that data, sends it across the link. The router or switch or other device on the other end sees this frame come in the trunk port, rips off this ISL header and footer, and then just examines the Ethernet frame just as if it were not trunked at all. So as you can probably tell, that's kind of computationally expensive. It has to take these frames and re-encapsulate them and compute checksums and so on and so forth. And it is a little slower than 802.1q trunking, but in most situations you'll never notice it because Ethernet speeds are just so fast that most systems and users can't keep up. So now let's move on and talk about 802.1q trunking. 802.1 trunking is IEEE approved, if you wanted to put a little label on it, meaning that if you have a Cisco switch and a Juniper switch and you want to set up a trunk between them, you could set up an 802.1q trunk. And both of those switches would understand it. 802.1q trunking is the standard method of trunking on modern switches. And again, going back to when we first talked about ISL, most Cisco switches only do 802.1q trunking. You can specify that configuration item, and we will do that in the configuration just to show you what it looks like. But for the most part, it doesn't support anything other than 802.1q, so there's no point in even specifying it. 802.1q trunking works very differently than ISL. Instead of encapsulating the entire frame, there is actually a portion of the Ethernet frame that is the VLAN tag, and within that VLAN tag you have priority and the VLAN ID and so on and so forth. But you'll notice that the entire Ethernet frame is not re-encapsulated like it is with ISL. You don't have an ISL header or footer or an 802.1q header or footer. Basically what the switch does is it manipulates what's in the VLAN tag, recomputes the checksum, and sends it across the 802.1q link. The receiving switch looks at the VLAN ID, verifies that the frame checksum is correct, and then takes this particular frame and just dumps it onto that VLAN. It doesn't have to remove the frame header or footer or recompute a checksum again before putting it on the destination VLAN. It just puts it out there, and it's a lot cleaner implementation, which also means that if you wanted to examine an Ethernet frame and it's using 802.1q trunking, you have access to the destination and source address and everything right here in the Ethernet frame. You don't have to crack open that ISL encapsulation in order to get at the actual Ethernet data. And that concludes our discussion of VLAN trunking.